Hello everyone, today we will solve question number 5 from random. So you need to pay attention to this part. Now let's solve this problem. This question, we have a position time graph given, so we need to draw particles velocity graph time, velocity versus time graph. So first of all, we should study this graph. So we have 3 different parts, basically 3 different motions. We can say this interval between 0 and 1 second, then between 1 and 3 seconds we have a different motion, and we can consider third part between 3 and 4 seconds. So first of all, let's start the interval 0 and 1 second. What we can see straight line. This straight line, and this angle is constant, slope is constant, so we can say this is a motion with constant speed, constant velocity. So here this part is a uniform motion. So motion with constant velocity basically. Now we need to find this velocity. It's simple. In 1 second it moves for 10 meters. So velocity, let's call it v1 equal to 10 meter per second. And this is a constant velocity between 0 and 1 second. Now let's continue. What about next interval between 1 and 3 seconds? We have again horizontal straight line, and as you see, position remains constant. So here it was 10 meter, after 3 seconds again 10 meter. What does it mean? It means this particle is at rest between 1 and 3 seconds. So we can say, let's call it v2 equal to 0, and this is also constant between 1 second and 3 seconds. Now last part, what we have again straight line, again this angle, let's say theta, slope is constant, so it's obvious that velocity here also constant. Now let's call it v3, and let's find numerical value, magnitude for this part. So initially, when time was equal to 3, position was equal to 10. After 1 second, at time 4, position becomes 20. So it's obvious that it moved for 10 meters in 1 second. So again, velocity will be 10 meters per second, and this velocity also constant during last 1 second. So between 3 seconds and 4 seconds. So how we can now draw our velocity time graph? Time in seconds. Here we have a velocity meter per second. This is a 0 for velocity and time. So here 1 second, 2, 3, and 4. Let me use different color. So between 0 and 1 second, velocity was equal to 10, positive 10. Be careful, this is a positive 10. As you see, positive 10, because slope is positive, because this particle is moving to the positive x direction. So velocity is equal to 10, positive 10, between 0 and 1 second. And then between 1 and 3 seconds, velocity is 0. So here, velocity is 0. Then again, between 3 and 4 seconds, velocity becomes positive 10 again. Positive 10. So here, 1 second, 3 seconds, 4 seconds. Here, velocity is 10, positive 10. This is the answer for the first part. Now let's continue. Second question. Does this particle have turning point or points? If so, at what time or times? turning point means it should stop and change its direction and it should go back. Yes? So in order to change its direction, velocity should become 0 after some time, and then it should go back. So velocity should become negative. So now let's come to this graph, and what we can see, we have a positive velocity. Yes, here, this part we have positive velocity, it means it's moving to the right side. Then velocity becomes 0. Yes, it's at station, it stops. In order to change it to go back, velocity should become negative. But now velocity again becomes positive. It means it will continue in positive direction to the right direction. So it means there is no turning point for this particle.